Hey there, David again. I have one last video on this series of tricks on compositions of circuits and proofs using cycles of curves. I wanted to mention that sometimes what you want to put in the public inputs is actually, too big for it, or it's just too large in a way that it's not efficient because public inputs are kind of expensive if you're handling them in a verifier circuit. As a verifier, public input is not that expensive, but as a verifier circuit, it's expensive. And I'm not gonna explain that here, but you can try and think about it. And if you don't find the answer, you can message me or write a comment on this video, and I'll see if I can answer that. So what do we do? Well, if this is too big for the public inputs, we might want to just put, sorry, we might want to just put one value in the public inputs. And this value is something that's derived from all of that. And if you know cryptography and hash functions, there's nothing magical there. What you can do is that you can hash all of your values, and then you can place the digest, the result of the hash function in the public input. The next person that will take a look at that basically will reconstruct the pre-image, hash them, and check that it's equal to the public input. Not that in practice, this is not always possible because maybe you were in a certain field when you did that, and then you have to do that same thing in a different field. And if your function is only implemented for one of the field, then you cannot really do this. So in our case, maybe when we go to the next verifier circuit, we cannot do this, but the next verifier circuits will be in the same field, and so we'll be able to unpack our values. And so if we want to pass something to the next verifier circuits in that recursion, maybe we might have to give the values in clear as public inputs. They'll take room. But if we want to pass it to the next verifier, which will be in the same field as us, then we can just pass a hash and then reconstruct the values in the next circuit. And I just want to mention here that the reason why we have different hash functions is that most likely you're not using SHA-256 or something like that, but you're using something called Poseidon or another. Poseidon is like a snark-friendly hash function that runs very well in circuits, but there are others, so you might be using another one. And so depending on the circuit in which you are, you might have instantiated Poseidon to work on that specific field. So you don't have access to the same hash function. There are two different hash functions because they're specified on a different field. Maybe this one is Poseidon FQ and this one is Poseidon FP. So something to keep in mind.